NASA's Parker Solar Probe, which has flown closer to the sun than any spacecraft, has beamed back its first observations from the edge of the sun's scorching atmosphere. To discuss, I was joined by astrophysicist and cosmologist at ANU, Brad Tucker, a short time ago. Brad, thank you so much for joining me this afternoon. Firstly, what did the mission find out?
So really this mission was trying to figure out why or where does this solar wind come from. So the wind does have a sun that blows through space, and this wind travels 1.8 million kilometers an hour, so it's pretty fast, and it actually creates and pushes a lot of the sun's material and hits the Earth. So the question is, where does it originate? And what they found is in the corona, which is the sun's photosphere, the sun's atmosphere really, little holes open up and then it kind of jet streams out, and this wind blows through space, slamming into the Earth. And if we can figure out where the wind starts from and how, we can then use that as a prediction tool to predict the solar storms it creates here on Earth.
Take us through NASA's probe. What does it hope to achieve here?
So, it's quite difficult because the sun is obviously a hot place. And one of the big mysteries is the surface of the sun is about 6,000 degrees Celsius, whereas the outside, the photosphere, the corona, is 4 million degrees Celsius. So why is this such a weird difference in temperature? So this probe is going pretty much closer than anything has gone before to essentially that outer edge of the sun's atmosphere to understand why these temperatures are different, how does the wind and the storms leave the sun and hit the Earth so we could better predict it, and just a better understanding of our star, our sun, because the sun is kind of the benchmark for other stars in space, so we have to know that to understand everything else in the skies.
And why has this been a long-standing mystery?
Well, it's simply down to the fact that it's challenging to observe the sun up close, right? To get there where you can see these things originate from. Obviously, we can observe the sun. Mount Stromlo, where I work in Canberra, was set up to observe the sun as part of a global project over 100 years ago. So it's been a source of study and experiment for centuries, essentially. But in order to really get more detail, you have to get close. So one of the big technological leaps of the Solar Parker probe was the heat shield, which sits on the side, and it's able to withstand temperatures of 1,600 degrees Celsius, which is why it's allowed to get so close that it does. But even that isn't enough, so it kind of has to point to the side of the sun, not look directly at the sun, and the same thing we do, to see the stuff coming off of it.
And Brad, in terms of a separate NASA mission, it's actually caught a nearby asteroid ejecting material into space. Take us through it.
So OSIRIS-REx has approached the asteroid Bennu, and now Bennu is a type of asteroid that's quite interesting. So instead of a big chunk, it appears to be kind of clumps that have come together, kind of like a snowball or something. And one of the big questions is, how do these things form? How do you get a clumpy ball of rock in space? And how solid is it? And the question here being, is it so solid that we can't break it up? Or can you actually fracture it and fragment it, i.e. if it's going to come near the Earth? Or can you fracture it to fragment it to look for minerals or things in the surface? So it's a big type of asteroid that is quite common that we know very little about.
And overall, how long is this particular mission?
So OSIRIS-REx has been in orbit around this asteroid part of the year, and in the very beginning it saw this rock ejecting off, telling us that it's quite loose and quite loosely bound, and the next year it's going to approach the surface and actually have this big vacuum cleaner go down to the surface and suction up a lot of rock as much as it can from the surface, and then it's going to come back and land in Utah so we can actually study the rocks up close and personal. So it's very similar to a Japanese-led mission with Australia, Hayabusa 2, but from a different type of asteroid. So, really starting to understand these objects in space, not only for the potential resources in the future, but how we can potentially direct them or redirect them if they're hit the Earth.
And Brad, researchers have for the first time found evidence of a giant planet associated with a white dwarf star. What is this? What is a white dwarf star?
So a white dwarf is something our sun's going to turn into in 5 billion years. So our sun is slowly growing, but really in 5 billion years it's going to puff out. And at that time, it's going to swallow up Mercury and Venus and Earth. And then it's going to shed its outside, kind of almost like a cocoon. And then the inside core is just going to be left over. And that leftover core is what we call a white dwarf. Still very heavy, still has lots of mass and gravity, but not a lot of other stuff. And so it's kind of the end of most stars' lives. And yet we know planets orbit stars. And a Neptune-like planet has been found orbiting around one of these white dwarfs. But more importantly, this star has actually gotten too close to the planet, and the gravity of the star is pulling off the atmosphere of the planet. So it's literally breaking down the planet in real time. So it kind of gives a clue to what's going to happen to the outer gas giants in our own solar system in that 5 billion years.
So is this a rare or unique discovery then?
Yeah, we have not found many planets around white dwarfs. It's really hard to do. It's really hard to find white dwarfs because they are so small and so they are faint. And really, we didn't expect to have a lot of big planets surviving this period. Again, if you can imagine, our sun is going to swallow up half our solar system, essentially. We don't expect many things to be surviving this period, but it does appear that they can. But if they get too close, maybe they don't survive it after all. So it's definitely, again, every week we're finding more about planets and their systems that they evolve and kind of the range. So anytime we think we understand something, it changes next week, which is kind of cool.
Well, it all sounds very interesting and always fascinating to speak with you, Brad Tucker. Thank you so much for joining me this afternoon.
Take care.